Okay guys, welcome back. So in the last video I talked about Charles law, how we can put Charles law, and explained to you about a simpler problem of using Charles law. So in this video I'll be focusing on Boyle's law. So Boyle's law is another gas law which can be used to solve the gas law problems easily. So Boyle's law is also easy, but the only thing is we have to consider what happens when Boyle's law and how can we put Boyle's law, how can we apply Boyle's law when we are given some problem. Okay, so let's start it. So Boyle's law. So Boyle's law. So in the theory of Charles law said, the Charles law explained that we can put Charles law only when the pressure and the mass is constant. So in the Boyle's law is a relationship between the pressure and the volume, not a relationship between the volume and the absolute temperature as in Charles law. The Boyle's law is explaining about a relationship between the pressure and the volume, and the temperature is constant now. Temperature and the mass of the system is constant. So the temperature is constant and the mass is constant. So Boyle's law explains the relationship between the pressure and the volume. So Boyle's law explains that if you keep the temperature and mass of the system constant, the pressure of a gas is inversely proportional to its volume. Right? The pressure of a gas is inversely proportional to its volume, means the pressure is directly proportional to 1 upon V, right? When the volume increases, pressure decreases, and when the volume decreases, pressure increases. So there's an inverse relationship between the pressure of a gas and its volume. So the Boyle's law's actual definition is that if you keep, right, Boyle's law's actual definition is that when the temperature right, when the temperature of a gas is constant, is kept constant, whose mass is also constant, the pressure of the gas is inversely proportional to its volume. Right? When the temperature of a gas is kept constant, whose mass is also constant, the pressure of the gas is inversely proportional to its volume. So this is not actually the definition, and in the Charles law, so this is not actually the definition. This is a simplified definition, right? So the actual definition will be something like that: for a gas whose mass is constant, if its mass is constant and if the temperature is kept constant, the pressure of the gas is inversely proportional to its volume. So this is not the actual definition of the gas. The actual definition, I am just using a simplified version to explain this concept, right? So this is the definition of Boyle's law. So P is directly proportional to 1 over V, or P is inversely proportional to V. So that means we can say, as in the Charles law, if P is directly proportional to 1 over V or inversely proportional to V, what we can say is that, as in the Charles law and in the problems in mechanics we found, if we have a directly proportionality or proportionality sign here, we can remove it by inserting an equal mark and a constant, right? So P is directly proportional to 1 over V. P is directly proportional to 1 over V means P is equal to K times 1 over V. P is equal to K times 1 over V. So we can say by cross multiplication, so this is actually the V is equal to K times 1 upon V, but the actual usage when we are using Boyle's law, what we do is that we say by cross multiplying here, PV is equal to K. So PV is equal to K. So K is a constant. So we can say that PV is a constant. So if PV is a constant, for some gas whose temperature is constant and its mass is a constant, if the pressure of the gas is P1 and its volume is V1, we can say P1 V1 equals K. P1 V1 equals K, right? And if for another gas whose pressure is P2 and its volume is V2 and its temperature and the mass is constant, we can say P2 V2 equals K. So P1 V1 is equal to now P2 V2. P2 V2. So when you increase the pressure of a gas, its volume decreases. So if you increase the pressure from P1 to P2, its volume will decrease from V1 to V2. If you decrease the pressure from P1 to P2, its volume will increase from V1 to V2. So that's the relationship between the pressure and the volume according to Boyle's law. So this is Boyle's law. So this is the equation that we will be using in the next when we are solving problems, because it's easy rather than deriving this equation from the basic concepts. So this equation we'll be using. So that's Boyle's law. So if we are to summarize this lecture, the Boyle's law says when the temperature of a gas is kept constant, whose mass is also constant, the pressure of the gas is inversely proportional to its volume. So P1 V1 is equal to P2 V2. So this is about the definition of Boyle's law. So see you in the next video with a practical example of Boyle's law, in which how we can find the quantities when we insert Boyle's law to a practical example under gas laws. See you then.